I'm using a list of sentences as input data for FeatureHasher. This is the text that I want to convert into numerical features. The sentences are: this is a sentence, another sentence here, and this is a test sentence. Think of it like I'm giving FeatureHasher some raw text to process. I'm using Sklearn's FeatureHasher with NFEATURES set to 5. This means I want FeatureHasher to output a feature vector of length 5 for each sentence. It's like I'm deciding on the size of the container for each sentence's numerical representation. It's all about the dimensions. The output of FeatureHasher will be a set of vectors. Each vector will represent a sentence, and each vector will have a length of 5. These vectors will be the numerical representation of my sentences, ready for use in a machine learning model. Cool, huh? This statement is true because I explicitly set NFEATURES to 5. Therefore, I expect each sentence to be converted into a numerical vector with exactly 5 features. This statement is generally true, but not always. While I expect the same word to mostly result in the same index, there's a chance of hash collisions, different words mapping to the same index. It's like putting things in boxes. 2 different items might accidentally end up in the same box. This is true. Because FeatureHasher processes words individually, the order of words will impact the resulting vector. Changing word order changes the final sum of the hashed word counts. This statement is false. If a word's hash index is outside the 0 to 4 range, because NFEATURES equals 5, the index will be taken modulo 5, basically the remainder after division by 5, resulting in an index between 0 and 4. The word will still contribute, it might just be added to a different feature than initially expected. This line shows the input data, 3 sample sentences. Each sentence will be processed by FeatureHasher separately. I'm using FeatureHasher, a function in Sklearn, to transform my text data into numbers. FeatureHasher uses a hashing trick to do this efficiently. I'm using Sklearn's FeatureHasher to convert text into numbers. It's like a special code that turns words into numbers a computer can understand. I start with a list of sentences. These sentences are the raw text data that I want to transform into numerical features so that the machine can learn from them. I use a FeatureHasher and set _n_features to 5. This means I'll get a feature vector, a list of numbers, of length 5 for each sentence. It's like creating a 5-dimensional space to represent each sentence. To create those numbers, the FeatureHasher uses a special mathematical function called a hash function. It converts each word into a number between 0 and 4. Because _n_features is 5. It's like a magic trick that turns words into unique numerical codes, making the sentences suitable for a machine learning model. The result? 5 numbers for each sentence. These numbers represent the words in the sentence in a way a computer can understand. This is what the machine learning algorithm will learn from. I'm going to test your understanding of how the FeatureHasher works by asking a multiple choice question. Get ready to choose the correct answers. This statement checks if you understand that the length of the vector is dictated by the parameter _n_features . That is, if _n_features is set to 5, then the output vector length will always be 5. Is this correct? This statement tests whether you grasp the idea of a consistent hash function. Ideally, the same word should always map to the same index. But is this always true in practice? This explores whether word order influences the final numerical representation. Does changing the word order change the vector? This is to test the edge case scenario. What happens if a word's numerical representation exceeds the limit set by _n_features ? I'm starting with 3 sample sentences. These sentences will be the input for the FeatureHasher, a tool that converts text into numerical data that machine learning models can use. These are the 3 sentences. This is a sentence, another sentence here, and this is a test sentence. The FeatureHasher will process these. I'm setting the _n_features parameter to 5. This tells the FeatureHasher to create feature vectors with a length of 5. This means that each sentence will be represented by a 5-element vector after processing. The feature hasher's output will be a set of numerical vectors, one for each sentence. Each vector will have 5 numbers, representing the features extracted from the sentences. Each sentence will be converted into a vector containing 5 numbers. This is because I explicitly set _n_features equals 5 . The FeatureHasher is a scikit-learn tool. I use it to convert text, like our sentences, into numerical features. I do this by assigning each unique word a number, and then summing the counts for each in a given vector. That's the basic process. Feature hashing is a technique used to map text features, in this case, words, into numerical vectors. FeatureHasher uses a hash function, essentially assigning each unique word to a specific position, or index, in a vector. However, because of how hash functions work, the same index could be assigned to different words, leading to collisions. I start with a list of sentences. These sentences form the raw text data that I'll feed into the scikit-learn's FeatureHasher. The FeatureHasher will convert these sentences into numerical vectors that a machine learning model can understand. I'll use the _FeatureHasher to transform text data into numerical features. The important parameter here is _n_features equals 5 . This tells the _FeatureHasher to create vectors of length 5. Each number in this vector will represent the presence or absence of specific words from the sentence. The _FeatureHasher output will be a set of vectors. Each vector will represent one sentence from the input list. Importantly, each of these vectors will have a length of 5, because I set _n_features equals 5 . The core of FeatureHasher is a hashing function. Think of it as a sophisticated way of assigning a unique numerical index to each word. For example, if I feed in the word sentence, the function might output the number 3. This number determines the position where the count of this word is stored in the output vector. However, different words might accidentally get the same index. This is called a hash collision, and that's important to remember. If the hash function outputs a number that's greater than 4, because I've limited the output vector size to 5, the modulo operator, %, comes into play. It finds the remainder after dividing by 5, our _n_features . For example, if the hash function gives 7% 5 equals 2. The word would then contribute to the second position of the 5-element vector. This means that even words that would normally be mapped to indices beyond 4 still contribute to the resulting 5-element vector. Finally, the _FeatureHasher creates the feature vector by adding together counts. For each word, this process increments the count at the index assigned to that word. Imagine I have a sentence like, this is a sentence. Suppose, this gets index 0, is gets index 1, a gets index 2, and sentence gets index 3. Then the vector would be something like 1, 1, 1, 1, 0. The order of words matters because it affects the final summation. I'll explain how the scikit-learn FeatureHasher works. It's a tool that converts text into numerical data that machine learning models can understand. Think of it as a translator that turns words into numbers. We're using the FeatureHasher with _n_features equals 5 . This means that FeatureHasher will create feature vectors with a length of 5. Each vector represents a sentence, summarizing the words it contains in this 5-element numerical representation. This directly confirms that every sentence will be turned into a feature vector of length 5. Each sentence will be summarized as a 5-number vector. FeatureHasher uses a hash function to assign a unique index to each word. Think of a hash function as a special number generator. I should emphasize that different words might end up with the same index because of collisions which might occur in this hash function. The order of words within a sentence matters because the FeatureHasher processes each word individually and sums their hashed values to create the final vector. Changing the word order changes the final vector. This statement is true, confirmed because we set _n_features equals 5 . This statement is also true, because FeatureHasher processes words individually and in the order they appear. A change in the word order will lead to a different vector. This is false. Words beyond the 5 feature limit are still hashed. Their indices are simply adjusted to fall between 0 and 4 using the modulo operator. In simpler terms, this means they are wrapped around the 0 to 4 range. It is like having a circular track for indices. I'm given 3 sentences as input data for the FeatureHasher. These sentences will be converted into numerical vectors. This statement is true because I set n_features equals 5 . Each sentence will be transformed into a vector with exactly 5 elements. Think of it like a 5-element container. This statement is generally true, but not guaranteed. The FeatureHasher uses a hash function, and while the same word usually maps to the same index, there's a possibility of hash collisions. Different words might end up in the same index. This is true. The FeatureHasher processes each word individually, and the order matters because the final vector is a sum of the individual word vectors. Changing the order changes this sum. This statement is false. Words are still hashed. If a word's hash value is larger than n_features, it'll be reduced using the modulo operator, the remainder after division by n_features. It means that the word still contributes to the vector, even if it causes a hash collision.